For those that don't know me, I'm Ian Pilon, a published author on a book about contextual intelligence called Cultivating Clarity. I run AI Agents Waterloo, Ontario. I'll share links to this after the podcast I'm running here, hackathons, meetup events, and I'm also running a new venture called Voice Claw that helps small business owners talk in text to their operational data. I run this podcast and talk to people way smarter than me. And we're going to meet Michael in a minute. And I learn all about AI and AI agents, as well as other things that just generally interest me. This show, we're going to cover a topic that I've learned through Michael around coding artificial minds, his new programming language premise, a blueprint for systems to build mental models. And another thing that's really interesting me about his work that hopefully we can learn here today is how this relates to agents, but also this topic of Stigmergy, if I'm pronouncing that right. And then get an update on GIL, Generally Intelligent Learner, a system that he's been working on. Joining us today is Mr. Michael S.P. Miller, a leading figure in the field of artificial intelligence and cognitive science, as the author of seminal works like Building Minds with Patterns and Coding Artificial Minds. Michael has made significant contributions to understanding and implementing intelligent systems based on Piaget theory. He co-developed the premise language and is behind the GIL system, which aims to create a generally intelligent learner. Michael, welcome to the show.
Thank you very much for having me in.
And to kick things off, you sent me an email just before we were getting ready to set up this conversation that you had won a top, I think it was in the top 3 of the Singularity Net AGI 26 conference. So congratulations on that. Maybe just, we haven't talked since last time we talked, but do you want to help us understand a little bit about how that went?
Well, basically, they had a hackathon, a build-a-thon, and one of my project was selected among 2 other projects as the top projects for the build-a-thon. And essentially, what the project did was, the ether, exactly. What the project did was create a connection between Omega Claw, which is their intelligent agent system, and the GIL system. And the way we made that connection was to assume that we had a virtual world, which we call the ether, and we have an interface to the virtual world, which we call a psyche program. And the psyche program gets percepts from the world and sends actuation attempts to the world. So that's basically what it was.
Very cool. And congratulations on that. So then maybe help the audience get an understanding of who you are. So, and what you're building. So there was that build-a-thon, but maybe just the elevator pitch for an audience that may have never met you yet, who you are and what are you building? What are you excited about right now?
So I've been excited about AGI, artificial general intelligence, for quite some time. I have worked on my AGI project, which is called the Piagetian modeler. Initially, a Piagetian autonomous modeler from around 2010, creating an architecture for a system that could operate like HAL or like any of these AI systems that you see in the movies. And I've been working on it for a while. Wrote several papers, submitted to various conferences, and around 2013, I decided, well, I don't want to code this in C, C++, or some very low-level language. So I set about with a partner of mine, Sheldon Linker, to create a new language called Premise, which is a combination of Lisp and a few other things. But essentially, it focused on messaging, rules, having a knowledge base with which to stigmergically interact, having agents where you can write an agent with 1 line of code, where you can have a web service with 1 line of code and have multitasking and so forth. So we've tried to put that all together in a language. We've finished the language in May of this year, well, the 3rd iteration of the language, version 3.3. And we finished the GIL generally intelligent learner, which is an instantiation of our original Piaget autonomous modeler system.
Yeah, and when we say, I think you've been at this a long time, are we talking like 2018 or when? How long have you been interested in the
Well,
in working on this?
I've been interested in AI for a long time since my undergrad, but I did the Piagetian slant. I picked up a book when I was about 16 years old called The Equilibration of Cognitive Systems, you know, The Development of Thought by Jean Piaget. Took me a decade or two to understand or grasp what he was saying. And then just by doing independent research, reading more of his books, came to, some understanding of what he was trying to do. And um, through understanding, kind of weaved together a cognitive architecture that is inspired by his work.
Yeah, very cool. And I've been looking into it now after I've met you around his concepts related to developmental psychology. And I guess I can see how you're tying that inspiration into your cognitive architecture. And then Gil, this model that I also watch some of your other YouTube videos. I'll do a quick screen share here because it was cool to see actually an image, right? So that helps people bring this abstraction into a real world sort of mental model about where your work ends up meeting the real world. So maybe you can help me understand this. So I watched this YouTube video of you talking about Gil, and I would love to know um, how you started back then and then where you are now with all of the iterations that you've been putting into the cognitive architecture. What does that look like? Yeah, just so I can sort of bring people to ground about where your work is applied because it's so relevant now with AI and robotics, but you were doing this a very long time ago. So maybe help us understand that journey.
So that was from October 2021 from the AGI conference. I put together a paper on the Piaget modeler. And in that paper and in that presentation, I talked about a robot that I have. So I have a robot, a Now robot, NAO robot. And that robot is puppeted by the cognitive system. So GIL is a cognitive system, Piaget modeler is a cognitive architecture, and the cognitive system uses an interface to drive the robot. And so basically, we've been working to enhance the system over the years and doing testing. And then eventually, we'll try to assess the age of the cognitive system of the GIL through various assessments. So we have actually there's IQ tests for children and for infants. There's one IQ test called the Bailey Scale of Infant Intelligence, and you can use that to assess the sensory motor capabilities of infants. So that's our first milestone to perform that test and actually see where the cognitive system is.
Very cool. Very cool. Okay, so let's talk about maybe this idea around the mind and and you gave me your new copy of your book. We'll get into that later, but I think what jumped out at me is this the difference between Eastern and Western philosophy and how you spell that out in the book to say there's almost two mental models where people think about this, and that was really cool for me to look at to go, yeah, like so, depending on where you are in the world, you're going to have a biased context about what you perceive yourself as, and then you now are talking about building systems that end up having minds. So it's really grounding when you can say there's multiple perspective of what a mind is. So you define a mind as a process that receives stimuli and produces actions. What's the difference between that and what ChatGPT does? Or is that too much of a jump to go into?
No,
east
that's
to
fine.
west to like robotics.
Yeah. So I define a mind as a system that takes in sensations from the world and it produces actions. So if you can imagine a biological being has signals coming in on various frequencies from the world, and that biological being takes those signals and filters them and generates a response. Now, the whole filtering process, I call it a bias process. I had a finance teacher a long time ago that says, we get data in and it goes through our bias filter and we come out with a decision. So it's kind of, and so two different people can see, a particular stock a certain way
Yeah,
and make two different decisions. One will buy,
yeah,
one will sell. So it's kind of the same thing. We have signals coming in, and then we generate a response, and then we have signals going out. For humans, the signals are muscle movements. For a cognitive system, signals can be sending messages to a device and having the device move in certain ways, perform certain actuations, or it can be sending a signal to Omega Claw and having Omega Claw, perform certain requests that Omega Claw perform certain things, or Open Claw perform certain actions, and then having the response come back from there. So it's a little bit different than just writing a textual prompt and getting a result from the prompt, even if the result involves doing a whole bunch of things, because the perception, the signal has to be more than just, text. In my mind, we would have for the cognitive system, we'd have a larger bandwidth than just, text prompt for as far as the input is concerned. We'd ideally have video streaming in, audio streaming in. In the case of the gill of the robot, we'd have joint positions. We'd have the odometry from the robot coming in, and we'd use those to to create distinctions, and then use those distinctions to form triggers, both logical triggers and emotional triggers and physical triggers. The physical triggers being actions, the logical triggers being what I call reasons, and have all of that culminating into a response.
yeah. And it's so, is it fair for me to say that you're taking the position of Western philosophy in that, based on what your book at the beginning was talking about, dualism and non-dualism, so that in order to build the things we are, synthetic minds, you have to take the Western philosophy because that's where distinction is made. And so that means you're just not doing Eastern philosophy at all. You're just taking the biased position of the
Yes.
Western philosophy. Okay. All
Yeah.
right, cool.
So
Because
the dualists, starting with Rene Descartes, believe that there is something called mind and something called body. There's a separation. And the Eastern philosophers, they believe in, a large percentage of them believe in non-dualism, which means that we are all just one substance and we're all the same. And in that case, it's not helpful in engineering a system. So we have to kind of assume that there is a dualism, assume that there is a mind and a separate body, and uh, start from that frame of reference.
I was just going to say, yeah, like I really liked how that's the starting of your book. Now I only got it a couple of days ago, so I've only got into the intro of it, but that really was a great way to open it up for somebody like me who has never seen the contrast between these two mental models of fundamentally thinking about how to think or how different people can uh, think differently, right? So when you're designing cognitive architectures, you just really have to lay this out here to say, well, you know, philosophically, there are many different, or not many, there's different ways to think about this. And it was really cool. And then also that you brought in Alan Watts, and then inevitably to your positioning on this, which I'm not going to give away your entire book, but I took little clips out that jumped out at me to say, you know, an artificial being cannot perceive the world without distinguishing itself from the world. So your point about distinctions, and then just starting your book off this way to say, this is how the cognitive system that you're developing, where it's coming from and why. Um, so, and then I was taking a couple screen grabs of this because I believe your book opens up with sort of this framing, which is probably a question I wanted to bring back to you. Yeah, this is how it starts, right? In the beginning, the creator made mechanism and the memory was without form and void, and darkness lay beneath the interface to the deep knowledge graph, and the mechanism of the creators acted upon the interface of the memory to create distinction. I use a mental model called DSRP to think about and learn stuff. Derek Cabrera anyways, it's his mental model about thinking about how to learn. So I really like how you started your book this way. It allowed my mental model to catch up to where it obviously grows in complexity, right? I love that you went down to this first principles about thinking about architecture. Yeah, go ahead.
So, first of all, I have to thank Yosha Bach because I
Okay.
watched a presentation of his back in 2024, and he framed the Genesis story as the genesis of human thought. And I said, wow, that was a really great frame for him to create. Frames in the sense of George Lakoff. So I'm a big fan, yeah, Yosha Bach. And I'm a big fan of George Lakoff and his work with Mark Johnson on image schemas, and also his work in language and frames. He wrote a great book called Don't Think of an Elephant. And so Yosha framed the Genesis story, and he actually gave a talk at, I think it was AGI 24, using that, uh, using that premise. And, and so I was really enamored with that. And, I sent a letter to him. I said, this is great. I'm going to use this for my book. And so,
Amazing.
yeah. And so, this is how it occurred to me, more literally in the words of Genesis. And what I see is that, we as creators, software developers, artists, we create these digital things, and, these are mechanisms. For me specifically, they have a specific kinds, but we create these mechanisms, and then there's a memory or a space, and we write these distinctions into this space. And so that's kind of what was coming along to me. So
I like it. I like it.
yeah, so
And
it's very good, and it makes it makes it kind of clear. We create these mechanisms. The mechanisms create the memory, and it follows in the constructivist uh, paradigm of Piaget. That we are constructing distinctions,
yes,
and these distinctions, work together, and it's basically what we have. The unique thing I think about people is that people are libraries of experiences, or libraries of distinctions, and everybody is unique. What the large language models are missing these days is the uniqueness. A
mm,
large language model is sharing uh, um, curated knowledge, but it's the same. Whereas individual people, you and I, have completely, we have overlapping, but completely unique sets of distinctions. And so that's the key to individuality. That's the key, I think, to creating these sentient and cognitive systems, is to allow them to grow individually.
Yeah, and then I think what you're leading towards on that, is it fair to say that people call those things world models or are developing world models when you're going down that path? Is that
So I like to use the term mental models. Kind of shied away from
okay.
world models, although I did use
Hmm.
that in the past because world models has become a lot of different things to a lot of different people.
Yeah, 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 yeah. That's
So
a
we are creating mental models, and those mental models perceive the world, come up with responses to the perceptions, and then can request actions be taken. Signals in, signals out, and a little bit
yeah, very
processing in between.
okay, very cool. I like where this train of thought is going. And you and I had met because you watched the show I did with Michael Levin and Katrina Shelsman on memory. And I think you said just a moment ago that the space that you're in the context you're using is memory. I think, or did you say
Yes, 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 correct.
it is, or it's not something else, right? So if I use my mental model and we go back to philosophy for a second, and I say I think, therefore I am, I'm in a space because I'm thinking about thinking. The space to me is I am just in something, even though that I may not know what it is. I'm in some space, and you're defining the architecture from when you're beginning as this space is memory. Is how do I catch up to you there? Where um, there has to be a a being in the space to start having memory. Like I think your
So
book starts here, but I'm like I'm trying to catch up to you even before that. When we say space, um, yeah, go ahead.
yeah, so as the caption said, in the beginning, the creators, who are the creators of this space, made the mechanism and the memory. So we divide right there. We divide the mechanism, which is the as in the CTMU. There's a gentleman named uh, Christopher Langan, and he says his theory is very interesting. If you haven't uh, taken a look at it, he's the cognitive theoretic model of the universe, and he says that there's something called a tellor, which is an agent, right? And the tellor acts upon the world. So yeah, you have an agent, you have a mechanism. For me, practically, a mechanism is one of three things. A mechanism is either an agent, a service, an agent which is proactive, a service which is reactive, or a rule which is opportunistic. But we have an agent, and the agent acts upon the memory, and the memory is a space to create these distinctions. And so in the space, in the memory, you're creating distinctions, and that's pretty much what you're doing the whole time. Now the thing is, these distinctions are typed, so you can create various kinds of distinctions. And so as we get on a little bit later, you'll see that this distinction is morphed. So the distinction could be what Leibniz called a monad,
Okay,
and then the distinction is morphed because it's changed. We add things to the distinction. We add a type or a relation to it. Then we add inputs and outputs. So the inputs are afferent signals to the distinction, and the outputs are efferent signals from the distinction, and that forms what we call a scheme. But that comes a little bit later.
so in your diagram here, correct me if I'm wrong, then the distinction of the space is the
Is that
bottom
little
part
black
that
dot?
yeah, but even before the dot shows up, I'm in space or something is in space. You have drawn a distinction between space and then set their below the
Yes,
graph below.
between mechanism and memory.
Yeah,
So
yeah.
there's a
So the
space for
bottom side,
mechanism
yeah.
is for memory. Yes.
Okay, the bottom is for memory, right? If I'm
Yes,
following you,
and
and
and the
the
top is
top
for
is mechanism.
mechanism. Yes, exactly.
Beautiful, beautiful. That's where I want to catch up with you, because I was like, okay, I just want to make sure I'm tracking this, because then I know the atomic sort of structure that you're building from. Because then from here, below this just becomes more nodes and edges related to nodes. So this graph knowledge below the fold in a memory substrate, or what
Yes,
you're calling a memory, I could catch up to you, because then it's like the complexity just scales astronomically, obviously here from there, and that's cool. But I always want to know the root of why we are building upon something. So this was really really fun to start off your new book, um, to go down this path, and I can't wait to read more. Is there, while we're on here, then it goes into here, and I guess this, I've seen some of your diagramming on some of your older work. Did you maybe want to pivot into talking some about this?
yes,
Where would you
sure,
like to go? Yeah.
sure, that's fine. So, when we talk about creating an artificial mind, um, in my early work, I was trying to identify, what are the divisions. So, in the upper area, we have a mind, and then the mind communicates with a body, and the body is situated within a world. And that world can be the real world, the 3D uh, physical world which we inhabit, or it could be the internet, which I called the ether, or it could be a video game, virtual world. So the bodies could be actual, like the robot, or virtual, like a character in a video game. The world could be actual, uh, it could be virtual, could, and then the body. When we look at the mind, there are a couple of areas of the mind. One is a perceiving area. So that area handles perception. So that's receiving uh, information from the body. There's another area called acting, and that's sending information to the body. And then we have the rest. Part of what has to happen is that once we perceive things, we have to be reminded of other things, and that allows us to spread activation around.
Oh, yeah. Yeah. Love it. Yep.
And then there has to be some sort of planning, for us to form new distinctions and also form actions and form reasons. Planning and reasoning are related. And then there has to be some sort of control mechanism that that allows us to orchestrate what's going on. And so that's the mind, one view of the mind.
Hmm.
And
It's
then
very very cool.
the next page, if you have a mind and body, they can be related one to one, in which case you have an individual mind controlling an individual body. It could be one to many, where you have one mind controlling many bodies. It could be many to one. You could have several minds controlling one body. In that case, you might be looking for consensus decision making, or you could be looking for failover. In case one mind goes out, you still have others as backup.
And
Especially if you're
sorry,
piloting an airplane or something like that.
the box represents the mind in this context, right, Michael?
Yes, yes, and there's a legend below as well.
Yeah. Okay. 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 Sorry to cut you off.
But
Keep
yeah,
going.
no, no, that's correct. That's correct. That's absolutely correct. And then finally, you can have a hive mind situation where you can have a controlling mind manipulating several subminds. This is what Ben Goertzel is building. He has a small project that he just recently started to do scientific research. And so he has one mind which controls several other minds. Um,
Did you
and
get to talk? Did you get to talk to Ben at the conference?
Yeah, yeah, we chit chatted, took pictures
Okay.
and so on.
All
Yeah,
right. Cool.
I've known
He's
Ben for years.
all right. Cool. Well, then we were chatting on X. I know, sorry for the side rant, but he was going to come on the show too. I got to follow up with him. I only met him once a long time ago as well in Colorado, but
Okay.
um, sorry to cut you off. Keep going. I was just on the topic where you brought him up. I want to get him on the show. So,
Yeah, that would be great. I think that would be a very interesting show. And then the other thing is that in the hive mind, the minds could be actually communicating along a bus as well, just exchanging
okay,
messages with each other on a bus. So it could be a central controlling mind, or it could be a bus.
very cool. And then if I tie that right back to the beginning of your book, this is why the distinction you made is so important at the beginning, is because we're using this mental model or this cognitive structure that there is distinctions between mind and body.
Yes,
So I really see that how that plays relevant as you move through trying to design these new synthetic systems. So very cool, very cool. And then this was interesting. Now that you got mind as a broker in this next graph, is that too big of a
yes.
jump to go from here to there,
No, no,
or
no. Go ahead, go ahead. It's fine. So once you have a mind, you can actually uh, do what Anthropic or OpenAI is doing and put those minds on a server. The only difference being that these would be individual minds as opposed to, curated shared minds. And so a person could log in on the website or via their mobile phone, create an account, and then download Psyche software to their phone or to their computer or even to their robot. So that's what the left hand side depicts. And so once they download the Psyche software, um, that software would communicate, in the case of a mobile phone, it would communicate with a broker. In the case of something, devices with more powerful CPUs, they'd communicate directly to the server, and they'd log in and then get allocated or reallocated a mind, which would work and interface with them, maybe control some external devices, maybe control the lights in their homes, or maybe do some order entry if there's somebody wanted to order pizza or something like that, or book plane tickets. So these minds would have psyches connected to external services, external devices, but you can have this idea of a mind server, which was something I put in my first book in 2018, Building Minds with Patterns. And, we have this today, except that these minds are just instances of, or slices of, the LLMs, LLM processing.
yeah, okay, slices, and then maybe correct me if my mental model's wrong, but I think of LLMs as minds, right? Because they were trained on whatever their data set was. And I use something like just the distinction between um, the East and the West to say if I was to, get all the books out of a library here I'm in Waterloo, Ontario, and I literally physically went to the library and had some capacity to download all the content of that library. It would be a lot different than if I went somewhere in Asia to a library there, and they would just they may have some books that are similar, but they would have culturally a lot of different context and books there, and then you scan all those and you download those, and even without an LLM, those two library of knowledges are distinctly different, right? Some
Yes,
patterns might overlap. They have a couple copies of, I don't know, Romeo and Juliet, just translated differently. But nonetheless, culturally, you have these biases where the knowledge around you starts to accumulate that is local, like cookbooks, right? So, cookbooks over there might be vastly different than cookbooks here. So I think of these just databases themselves as being distinct. And now the LLMs just basically were able to build a synthetic neural net of the data. Um, and I think of those as minds. Is that a fair way to think about LLMs, or would you describe it or define it any differently?
um, we can think of them as minds. That's a fair assessment. In my opinion, though, the kind of minds I'm building are tabula rasa, so they're blank slates, and so they don't start completely filled. They start empty, and they interact with their environments, and then they build from zero. So they kind of follow that pattern of creating the distinctions on the fly, and then
Yeah,
integrating
yeah.
the distinctions. And so these are what I call learners, as opposed to a large language model which is already pre-filled. This is a intelligent learner which will create its own distinctions based on what it perceives. And so it will have all of them will be unique because they all have different perspectives on the world, different interfaces to the world,
Hmm.
and they'll be able to do different things. They'll have different capabilities, and it'll be interesting to see what they ultimately do and how they ultimately compare. They won't have. So I wrote a paper last year called "Building Sentient Beings," and in the paper I made a distinction between eidetic oracles. So eidetic means having accurate and vivid photographic recall, and an oracle is someone you go to for advice. So I call them eidetic oracles. And so the sentient systems I wanted to differentiate from the eidetic oracles. So
Okay.
so ChatGPT, Claude, all of these I call eidetic oracles. They have phenomenal recall and they give you advice. So the sentient system is kind of the opposite. It is perceiving, it's embodied, it exists in our reality, and it has emotions, but mostly it has situational awareness. The
Love it.
perception allows it to have situational awareness. The perception allows it to identify what are the elements in the immediate environment, what are the elements in the immediate
Yeah.
milieu, and for those elements in the environment, what are their trajectories? And that's where world model thinking comes in. But also, what are their intentions? That's where the mental model thinking comes in. What are these elements intending based on prior experience? That's where the reminding and the recall comes in, and the planning. So, so a sentient system is a system with situational awareness, which can discern these things, based on its increasing experience.
Yeah, and I love this line of thread because I've been trying to make a distinction between what is sentient and what is not, and um, I was sort of stuck on using emotions as some sort of chemical composition that robots don't have, and using that as a distinction. And I think what you described is it's so much more, way more. But I guess to come back at that is like you can't give robots emotions, or can you, or how do you make up for the fact that if you're talking about building sentient beings, you can't build in emotions or into them, or can you? I don't, maybe you
Um,
can.
so we are chemical systems. We are biological, biochemical systems. And so we feel emotions because emotions trigger feelings in us. And there are a number of books on emotion, which I've read. And essentially, our emotions prepare us for a particular state, whether they're preparing us for fight or flight or other states, right? So these are chemical transformations that we undergo. Now, in a cognitive system, we can have a version of that, but not exactly the same. They won't feel emotions that people feel, but we can design emotions along different dimensions. And those emotions can be ascribed to elements in the environment And all the emotions can also be ascribed to the system's self, right? To the system's self model, to identify what state the self is in. So some dimensions along which we can define the initial dimensions are, I would say, would be valence, a notion of good or bad. We can have that on a scale of -1 to +1. So if something is we ascribe as good or something we ascribe as not good, that's an initial dimension. Another dimension we can use is arousal. They call it arousal. Whether something makes you excited or whether you're indifferent to it. If you're indifferent to it, that could be -1. If you're aroused by it, if you're excited by it, that's +1. So we can have a feeling of excitement or not excitement. If we see a puppy, that can have a positive valence and a positive arousal, ascribed to it. When we think of puppies, they're barking and jumping all over the place, and then there are other dimensions which we could also add. Another dimension is called approach. An approach tells us whether or not we are pulled towards something or pushed away from something, right? So there's a attraction or repulsion on that dimension of approach. So if you think of something that's doesn't look good, we're not pulled towards it; we're pushed away from it. If
Mhm.
you see someone who is of the opposite gender who
Mhm.
looks stunning, we're pulled towards that person.
Mhm.
So that's another dimension along which we can have emotions. And then the final dimension we can have is power. In the power dimension, we can have dominance or submission. Do we feel dominant to this element in our environment, or do we feel submissive to this element in our environment? And so all of these dimensions can be ascribed to different things. This is our emotional set, and and we can use these emotions to navigate the world, and navigate how we deal with different items in the world.
Yeah. And when we talk about the tabula rasa, if I was to have a robot, it doesn't know, it doesn't experience pain the same way we do. So if I burn it, it doesn't have a negative reaction like us where we actually feel the pain. So that's where I think that you can't have sentient robots from the emotional standpoint that they're not experiencing what we're experiencing. I know you could probably try to simulate synthetic degrees of emotion potentially in systems and say, well, this is how we react, so maybe you should react that way. But that's the only thing that where I still haven't seen a good argument to say that you can't have or way it's the way that I look at the difference right now between me and as a robot is I know that if I approach the fire even as a baby and burn my hand, there is an emotional chemical reaction to that, and now it's in that wetware forever, right? Where for if a robot goes to it, it'll just sit in the fire until something burns down and doesn't have a reaction to that.
There
So
are
when
there
people
there
are
are people there are people who are wired a different way, and they don't have feeling. So they will burn their hand and then just leave their hand on the hot stove or something. And not
okay,
very many individuals, but there are people who don't have that feeling of pain.
so I think you're frozen there. Hopefully the system catches up. Your screen is frozen. Are you still with me,
I can hear
Michael?
you just fine.
Okay, let's let your system catch up. Okay, it's catching up. Okay, it's caught up. Hopefully, we don't lose any of that. We can get that. But let's let's pivot then to sharing some of the other brilliant work you're doing, because we've touched a lot on the cognitive architecture, which are sort of blueprints that you're using to build mental models. How is that related to premise and the coding language that you've built? And how does that help the audience that watches the people I have on the show, which are building AI agents? So is there a way that you could tie some of your work into why anybody should care that builds AI agents in your
Yes.
premise language? Yeah.
Yes. Can you hear me?
Yep. Yeah, we got you loud and clear now.
Okay, great. So again, back when I started, after I made my first iteration of the Piaget modeler architecture, I said I'd like to code this up, but I didn't want to do it in SQL or in C or C++. At the time, I felt that that was very low level, and so I thought about it, and I read a little bit about Sapir and Whorf and their hypothesis that the language you use influences how you think and actually shapes how you think about things as a strong and weak version of their hypothesis. So I said, the language I use, I want to have very high level intrinsic functions. So I want agent to be a function in the language. I want service to be a function in the language, an intrinsic in the language. I want to be able to create relations with one line of code, and I want to be able to create rules and queries over those relations. And mostly, I wanted to be able to share the information. So in the mid 90s, we had our first wave of agents. And I detailed that a little bit in the Building Sentient Beings paper. Ornetzioni and Daniel Well out of the University of Washington made softbots circa 1994 and 1995. And those were agents that you give it some instructions via web user interface, and they went out and did some tasks for you. And then shortly after that, we got the Federation for Intelligent Physical Agents, and they created protocols and specifications for agent interaction. And then we got Jade, the Java agent development environment. So this was all happening in the 90s. And so, there's a huge body of work that already exists on agents, which, it seems that somehow we've forgotten. But those of us who's been around long enough, can leverage that. And so I created a programming language similar to Lisp, lots of insidious, silly parentheses, but that's a lot of parentheses in the language. But the language differs from Lisp in that if you type ABC in Lisp, it says unbound symbol, whereas if you type ABC in premise, you'll get back ABC. You just have a literal. What premise allows you to do is to build multi-agent systems very quickly and build multi-agent systems that share common substrate. So we use the word stigmergy. Stigmergy is how ants communicate. They communicate by leaving pheromone trails. You can think of Facebook as a stigmergic system where the ants are like people. The ants are agents, and the users create posts. So they'll post a picture, they'll post a comment, they'll post an article, they'll post a video. That creates a pheromone in Facebook. And then other agents, other people, other users come upon that particular pheromone mark, and they will react to it. They might like it, they might dislike it, they might comment on it. It might trigger other reactions and so on. It might trigger a flame war or whatever. And so that's a stigmergic system. A stigmergic system is where an agent places some record into memory, and other agents read that record and act upon it. And so that's a stigmergic system. That's what premise facilitates. In premise,
Very
any agent can leave pheromone trail. Any agent can create a record in memory, and other agents share that record, and then they can act upon it or delete the record if they want. The records in premise are called thoughts, THOUGHTS. So they're creating thoughts in the memory of of the program.
very cool. That's the first time I've heard anybody doing anything like that. Is it safe to say, so if the agents are leaving trails of some kind in a substrate of some kind, and there's no activation or agents being like going to use that trail, that it fades over time? Or is it just locked in even though that it's left some little digital trail? Because the thing I struggle with thinking about long-term memory, or what we talked about on the show with Levin around like getting away from the idea that memory is storage, is inherently in biology. We do this, we let things go, and because they're no longer serving our current and future goals. So it's really, I haven't seen a clever way to do that in digital systems, because everybody saves absolutely everything, and now you have a scalability problem where your system is just going to get bloated because it's trying to remember everything that you don't need. So can you use what you're describing here in any way, in novel ways, to deal with not sort of like storing everything, but maybe having a trace that can fade? Or do you see where I'm going
Yes,
there, or am I just way out of it?
absolutely. So if you, there's in the book Coding Artificial Minds, there's a diagram of the Piaget modeler. There's a colored, first color diagram. And in that diagram, you see a circle, which represents the world. See a circle inside it, which represents the body. There it is. Yes, that's it. If you can zoom in on that. So what you'll see is the body, which is going to be manipulated, whether it's the psyche, whether it's going to be a robot or a program, that's fine. And then the psyche communicates with the mind, which is the box. And there are different classes of mechanisms. You have observation mechanisms, which exchange information with the body. You have coordination mechanisms, which add extra inferences. This would be adding reasons. This would be adding uh, actions. This would be adding objectives to the memory. Then you have reflection mechanisms, and the reflection mechanisms would alter the overall behavior of the system. And then finally, at the top, there are consolidation mechanisms. And the consolidation mechanisms, the consolidation mechanisms, yeah, stigmergic system. It's stigmergically, it's all
Yeah,
acting
I'm trying to
stigmergically.
visualize how this, yeah, trying to visualize how these two work together. Keep going. You're doing great.
And the consolidation mechanisms at the top are the ones that are responsible for forgetting and
Oh,
for automaticity and
oh,
for recycling and for compression. So when you have a couple things that are pretty much the same, you can compress them into one and throw away the residual or throw away the extra. You can canonify them. Or if things have been around for a long while and have low usage, low integration, you can get
yeah,
rid of them. If behaviors or actions are used in sequence, you can combine them, and so on. So you have consolidation mechanisms to
very
constrain
cool.
the growth of the memory.
Yeah, this is making
That's a
me
key
think
part.
of, yeah, this is, thank you for pointing this out. This is going to help me refine my mental model on how that potentially can work.
The
Where,
activation spreading is the activation spreading is part of coordination.
okay,
Yes, absolutely,
and I'll
absolutely.
tell you why I pulled that up there, because when you say this, it makes me think of a mental model that I sort of been thinking about, and then got Claude to build me a model of, and that is the idea that in context timing matters to how I remember events. And I was really wrestling with what I was talking about with Katrina and Levin was, so ice cream, for example, can invoke memories inside of us, and it's not like one storage thing that says this is what ice cream is. It's a relationship to all the experiences you've ever had with ice cream, plus the context you're in now related to the recall of the relationships of that memory. So you could be sick and somebody says the word ice cream, and the activation in your memory lights up differently based on the current state of your being. I'm sick, so my memory has a different recall than if it was I'm not sick, I'm healthy, or it's sunny out, and the relationship of memories I have related to ice cream is different. And activation can mean I remember, I maybe not remember, but there's a memory in there somewhere related to when I was sick as a child. My mom gave me ice cream, and I have a feeling, emotional response to being sick and ice cream having this other activation around the word ice cream versus,
Absolutely.
I'm not sick, I'm actually healthy, but the sun is shining and I have this other memory. So when you say activation spreading or things of that nature, it makes me think about not only coordination, but I'm, yes, trying to see the consolidation part, which is at some point, if there was a long enough time horizon, these memories don't get activated, right? They don't get recalled because, I don't know, let's say your parent or loved one passes away. And if we lived a lot longer, that activation may not be getting recalled. So it fades. And I think there's a relationship between coordination and consolidation. Well, I guess in your box, there's a relationship between them all, right? Like, I guess they're interplaying on each other all the time. Is that true? A fair statement?
Yes, and actually, if you go a little bit further, I don't know how many images you took, but
Uh,
there's a breakout. There's a breakout,
that's
and
all
I
I
don't know.
got.
Maybe I can share
Yeah,
what I.
sure. Go right. Go right ahead, Michael.
Let's see. Let's see if I can share. Okay. Let's see if I can share. Share. We'll try it, and let me know if there's any
Yeah, I'll let you know.
degradation.
Yeah, I'll
Okay.
let you know if
Thanks.
the audio starts sketching out.
Okay.
Okay. Hide
Can you
that
see
screen.
this?
Yeah. There we go. Yep, we got it. And your audio sounds good, Michael.
Okay. Great. So this is base. So right. This was the system that you just showed. This is the architecture for the Piaget modeler, and it's made of design patterns. So the design patterns is the mechanism base. So we have design, it breaks down into many design patterns. And a design pattern is basically the connection of mechanisms, which are the boxes, to some relationship in memory. So when you put it all together, it kind of looks like this as a data flow diagram, when you put all the design patterns together. Now, Piaget modeler is an architecture, and GIL is a system, an implemented system. Let's take a look at the memory. So, we have a neuron. Everybody knows what a neuron looks like. This is a neural proposition. A neural proposition can look like a neuron because it has elements that are related to the axon, elements that are related to the soma, elements that are related to the dendrites. But on the other side, on the propositional side, it has what we call reifiers. So these are the monads, or the IDs. It has a positive and a negative ID. So 3005 is the positive aspect or the affirmation, and negative 3005 is the negated reifier. That's the dyad. It's the opposite. It has a predicate, which is the data type, and it has terms, which are inputs and outputs. This is a neural view of it. Here we see at the bottom a neuron with glia and dendrites, and then it has a synapse. Well, the synapse is the reifier in my case, and you have a positive synapse, which we call the thesis, and a negative synapse, which we call the antithesis. And it's all hooked into this activation structure. So you can activate the positive or the negative in different, what I call realities. Observed reality, the things that you are seeing, perceiving in the moment. Desired reality, the things that you want. Recalled reality is when something reminds you of something else. You can recall it in memory. And these are all different activations. Something can be activated in your mind as recalled, and as well, being seen, but not desired. It's not something that you want.
Interesting.
So these are
Yeah.
different kinds of realities. And then you can have beliefs, some belief parameters associated with the thesis or the antithesis, with the positive reifier or the negative reifier. And so this is what I call a scheme, and this is the graph unit. Charles Simon calls this something similar. He has something similar called an atomic thought. But basically, you have the reifier, which is just an ID. It's a number from 128-bit number, positive or negative. You have a relation, which is the type. You have the arguments that come in and the reference that go out. And with it, you can build schemas. A schema is a hierarchy of these units. So for an action, an action has a context. It has the goals or the series of causal actuations or actions to perform. It has a loop element. Are you going to do this action once, or are you going to repeat it until some condition, or repeat it while some condition is going on, or just repeat it for a certain count? And then it has an expected result. This is an action. And it's a schema as opposed to composed of individual schemes. You have a reason, which is a logical proof. These are reasons. This is what we have in our brain. We do things because of reasons. A reason has premises. It has some known background information. It might have other reasons which are, supporting it. You could have a logical proof, and then it has a conclusion or a theorem. So these are schemas. This is an individual scheme, and the scheme's composed to make schemas. And this reason or action, those are the relations. Those are the types. And we have many, many types, not just reasons or action. And so we have all of these fitting into the memory space. The memory space we call the totality. And the totality is that circle in the middle. It's the space. And this totality has different areas. It has a perceptual area. It has an imaginative area. It has an ontological area. It has an associative area, and it has an activative area. This activative area is what you were talking about just now. And then this would be an entity relationship diagram of the totality, where in the perceptual area, you have percepts coming in. You might have predefined icons and geons. Icons are two-dimensional shapes: circle, square, rectangle, triangle. Geons are like boxes or spheres, things that we can pattern match on. Then you have other shapes, you have objects, recognized objects, you have the scene, the overall picture, image. Then you have what I call image schema, which are relationships of these objects, shapes, percepts, geons to each other. You know, image schema is the work of George Lakoff and Mark Johnson, where you have behind, together, apart, different kind of relationships. You get into the imagination, and imagination is mental canvases, kind of like mental canvas, kind of like Unity or Unreal Engine. It's a canvas where
Okay.
you can imagine and dream. And in that, you have a camera angle or a vantage. You have a collection of things that are to be arranged. You have what I call figments of your imagination, which are the objects. And those objects are represented as meshes or clouds. And then you can have an animation, which, animates them. So this is your imagination. In the ontology, you have the basic scheme, which we looked at earlier, and you have beliefs, emotions, needs, usage count, how many things are using the scheme, that helps forgetting, and utility, how good is the scheme. You have, the source of the scheme, then you have the arguments, reference, and relations. The scheme ties into the associative memory. Associative memory basically is two things. It's traits and cases. You have a bunch of features of something that stimulate the overall retrieval of specific content. So traits and cases is your embedding space. The traits could be tokens, and your case could be the content that's retrieved by the tokens. Associative memory is very simple. And we've been doing associative memory for a long time, since the late 80s, when it was called case-based reasoning. Now we have different vocabulary, but it's basically still the same thing. And the most interesting thing is the activative memory. I call it activative. Some people say context, but it's really how you spread activation. You have activations from a particular point of view. Our default point of view, I call general awareness. And then you can create other viewpoints. When you identify who the self is, this grasp of consciousness that Piaget talks about, the self could be one viewpoint. And then you can have other people's perspectives as different viewpoints. So we can activate things according to viewpoint. You have glue, which puts the distinctions into a Euclidean space. You have an agenda of objectives you want to attain. You have the realities that we talked about earlier, and so forth. So this is the totality. This is the box in which everything resides. In the totality, we have these distinctions. These are the reifiers. These are the monads. And they're placed in the totality spatially, because they can be connected or they could be activated by proximity. So if they're located in this three-dimensional space, when you're reminded of something, it could set off things that are also close to it, but not necessarily connected. And then the totality has tiers. And what we're building in the totality, what we're constructing, is this ontology. We start with percepts at the bottom, and we go all the way up to theories and maxims and lessons at the top. And you have different areas. You have the perceptual area. Percepts come in, they get featureized, and those features are used to index to percepts in associative memory. You develop concepts over time. You have entities, which are assemblies of active items. You have events, behaviors, you have episodes, operations, you have stories. So we're building up this ontology over time. I know it's a lot to go through, but we
Oh,
have up to, go ahead.
it's the audio starting to break up, but no, this is great.
Okay. So anyway, this is what you'll learn about in the book. Observables,
Very cool.
image schemas, above, across, apart, together, path, container, simple circuits, vertical circuits. Things are similar, things are equivalent, things are identical, things are incompatible, things are different. You have different gates, structures, classes, concepts, ideas, prototypes, and so on. These are all the relations that are fill in the neural propositions. So anyway, that's
So
that's pretty
then,
much.
yeah, no, this is great. Thank you so much for sharing that, Michael. I think it's a great segue into getting your book out there so that people who are interested in not only cognitive architecture, but just building agentic systems, I think can find huge value in. So we are coming up close to an hour. So is there anything else we didn't cover that you thought would be relevant to get in? That we can have the floor to share anything else that maybe we haven't talked about so far that you think you'd love to get out there?
Well, I appreciate the time you gave me, Ian. And the first book that came out was called Building Minds with Patterns. That's available on Amazon. And that, sets the groundwork for the latest book. And the latest book is called Coding Artificial Minds. And so Coding Artificial Minds puts actually some source code, gives a sketch of the gill system. It doesn't give everything that's in the gill system, but there's only so much you can fit. It's about 450 pages already, but it gives a source code and it shows you, what can be done in this framework. And so I think this
Very
is an
cool.
inflection. I think this is an inflection point in AI at this point. And I think things are really going to take off as a
Why do
result
you
of,
think it's now? Yeah, why do you think it's now, Michael? What makes you think now is the inflection point? What changed?
well, so Thomas Kuhn wrote The Structure of Scientific Revolutions. And he says basically when the current paradigm can't answer, certain questions, when the current paradigm struggles to answer certain questions, then it's time for a new paradigm to emerge. And the questions that the current paradigm can't answer, how do you build a system based on perception? How do you grow a mind? These are some of the questions that this new book answers.
Very cool. So I will add your links to those books and where should people follow you? I'll add that below, but how do you like to be found if people want to reach out and find you other than buying your book?
People can find me on LinkedIn. I have a YouTube channel. It's @ cognitive architectures, all one word. If people really want to reach out, they can send mail. If it's on the premise language, they can send mail to premise.ai@gmail.com. And if they want to reach out to me directly, they can reach me at subthought, SUBTHOUGHT, at hotmail.com. That's
Amazing,
basically it.
Michael. Yeah, it was such a pleasure to have you on the show. Thank you so much for sharing all your wisdom. I learned a ton and I'm going to share that with my audience and add the way that they can find you in the show notes. So thank you so much, Michael. I appreciate your time.
And thank you very much, Ian. I appreciate your graciousness in letting me come on your show. Thank you.
Thank you.